Hey, Matt 140, this is Dr. Roach, and we're going to be working on section 4.1-4.2, and I'm just going to be working through the homework assignment. Just reminding you about a few things. If you look at my PowerPoint notes on the module, you can get some details about where some of this is coming from. But let's start off with question number 1 here on the homework. So this is a cubic polynomial. I've got to be careful. It's in the wrong order, so this is a cubic. Now, cubic polynomials look something like this, or they could be a different end behavior. They could look like this. This is more negative x cubed, and this one is positive x cubed. So the end behavior is affected by this negative on the outside. The cube is a little bit about the end behavior. If it's an odd degree, you will have opposite infinities. And what I mean by that is this is coming out of negative infinity and it's leaving at a positive infinity. Odd degreed polynomials have that end behavior, but they could also have the opposite one where it comes out of negative infinity, comes out of positive infinity and leaves at an negative infinity. So just be aware that you have those two possibilities for odd degree polynomials. So the leading term of this polynomial is x cubed. The leading coefficient is a 1. It's hidden in there. It's 1 times x cubed, and so we don't write multiples of 1 in the final representation of the function. The degree of the polynomial is 3. That's the highest power of x, and the polynomial is cubic. All right, let's keep going to some more here. So really right now we're talking about end behavior, overall degree, and the leading coefficient. Now this leading coefficient is negative this time, whereas this function behaves roughly like negative square roots of 3x cubed. All the other stuff, it has an impact, but it's more of a local impact. It has less of an impact on the ends or the end behavior. And since we're dealing with a negative up front, that's going to have the end behavior that goes like this, coming out of positive infinity and leaving out of negative infinity, like that. So that's going to be B is our choice. D would be another possibility. That would be if that had been a positive leading coefficient. All right, let's do one more on end behavior, and then we'll start another video here in just a second. So select one of the 4 sketches, A through D, that follow to describe the end behavior of the graph of the function. Now, this time our degree is 6. Degree is 6. It is roughly going to behave like negative pi x to the 6th. Like all the other stuff just affects the local internal behavior as far as it having turning points. So p of x, we could get out our calculator, but roughly it's going to come out of it's going to come out of negative infinity because of the even degree. So it's going to come out of negative infinity, and it's going to wiggle around. This is that local behavior I was talking about, and it's going to leave at a negative infinity. So there we have it. That's the rough end behavior, and the wiggles on the inside are going to be affected by the lower degree choices. So what I'm saying is we're looking at A here. This is the end behavior of an even degree polynomial with a negative leading coefficient. The other possibility would have been B. That's for positive leading coefficients. Anyway, thanks for watching. We'll hit another video here in just